Welcome to another mini lecture. Today what we are going to do is to review some basic topics from introductory algebra classes related to square roots. So a couple of problems related to multiplication of square roots, a couple of problems about the quotient or ratio, and a few problems about the rationalization of a fraction. So all have the same theme of dealing with square roots. So how do we handle these type of problems? So here it says simplify this product. What's important is to factor these radicands. The number inside the radical is called the radicand. Factor them to a product of a complete square and another number. For example, 24, we write it as 4 times 6. Reason for that is that 4 is a complete square and comes out of a radical. 6 might stay inside. Same with 54. So we have again 9 times 6. Of course, there are many other factorization as well, but we separate the square part versus the other part. You remember a few lectures ago we had a recommendation that you memorize all sorts of powers, at least all sorts of squares, like 1, 4, 9, 16, 25, and so on. So what happens here, I have 3 square root of 24 times square root of 54. This is 3 square root of, this is 4 times 6 times square root of 9 times 6. So 4 comes out, so becomes 2. 9 also comes out and becomes 3. And we are left with square root 6 and square root of 6. Well, multiply 2 square roots of same number, you just get that number coming out, so it becomes 6. 3 times 2 times 3 times 6. So you multiply 6, 18, and then 6, so this was 6 and this is 18, and then you multiply by 6, same problem here, so let's be a little bit faster here. 4 square root of 45, I write it 9 times 5, and 75 I write it, what do I write it as? So that's going to be 25 times 3. Is that right? So rewriting this thing again, it's 4 times 3 times 5 times square root of 5 times square root of 3. So I'll have 12 times 5, 60. Square root is 15. So remember, square root of a times square root of b, you can write it as square root of ab, so long as a and b are positive numbers, or at least 0. We have that. If they were negative, we are going to talk about that later on. So so again, what we learn here is to factor so that the complete square are separated, so that they come out of the radical, and we manipulate them outside of radical, and then inside radicals we multiply them with this product property. Similar problem when you're dealing with a ratio. So quotient here simply means a ratio. Here you can use the following: ratio of 2 square roots, you can write it as square root of the ratio. Notice we have an order of operation issue here. So what is it that we do here? We are taking square roots and another square root, and then later on we are dividing these two. What we are doing on the right hand side is that the division happens first. So we have a over b, let me color it first, So we are doing the ratio first, and then we are doing the square root, as opposed to here we are doing the square root and doing the ratio later. That's the story you should learn here, more so than just playing with the numbers. So here what we learn is that you can do 58 divided by 2 first, and then, well, that's 29, and that's the simplifying this ratio. The word simplify is a very general word in mathematics. It is something that you learn by practice. There's no set rule that one can say to say what does simplification mean. It's something that you learn by practicing many problems. So would you agree that this is a more complicated expression than that, or radical 29 is simpler than that? So in mathematics you are always looking for a way of cleaning up a result and writing it in fewer steps or fewer notations and so on. So let's go ahead and look at another one. Simplifying a quotient again. We can write it 6 over 54, and then this can be written as, of course, we can simplify by a factor of 6, and then we notice that, well, 9 is a complete square, and then we write it like that. So again, the main issue to learn is the idea of simplification. Where is it that I should stop? Okay, is that the end? Is that the end? Is that the end? And again, this is something that you learn by practice, and a simple rule for simplification cannot be given. It is by maturity more than anything else. Okay, something that we are going to build on top of the ideas we learned here is the idea of rationalization. So rationalization is something that is going to be with you for a long time and gradually become more and more involved type of rationalization. The idea is that, well, you have one activity to do and another one and then the third one. The question is, can it be again made simpler? Well, what's so complicated about radical 2 over radical 3? You can think about it is that you have to take 2 square roots, and square root is not a simple operation. If we can reduce it to just 1, well, we have saved some time. How do we approach this thing? So idea of this simplest idea of rationalization of a denominator. If a denominator is just simple square root, you multiply it by itself. So radical 2, radical 3 that we have, we multiply by a copy of denominator in both numerator and denominator. Why so? Because in denominator, when you multiply these two, the radical goes away. Radical 3 times radical 3 is just 3. In numerator, this simplification is that, well, we just apply the idea that we learned here. You can compress it inside one radical. So radical 2 times radical 3 is just radical 6. Now again, the issue is the spirit of the problem. What is it that we have achieved? On the left hand side, we have 2 radicals to calculate and a ratio. On the right hand side, we have only 1 radical to calculate and a ratio. And if you think about the economy, you can say the right hand side is cleaner. Of course, we could also say rationalize the numerator. The problem is not asking that here. It says rationalize. If it had said rationalize numerator, so radical 2 over radical 3, you take it and multiply by radical 2 now. Radical 2 times radical 2 is just 2, and denominator is 2 over denominator is just radical 6. So these are all same, they are same quantity. This is same as that, and that is same as this one. What is it that appeals to you? It depends on the problem that you're looking at, what you want to do. Here the clue as to what is expected for you to do is rationalize the denominator, and that is what we did. Okay, another similar problem. It says rationalize the denominator and simplify. So I take this, multiply by another copy of the denominator, and I get 6 radical 10 over 10. It says simplify, so there we could still be looking towards simplification. Well, what is it that we can do? We can just simplify by a factor of 2. This becomes 3 radical 10 over 5. Okay, practice topics from algebra, perhaps algebra 1, but pretty soon after this course you're going to be moving up to calculus, and they will be asking you to rationalize expressions that are not necessarily just numbers. So you might have something like 1 over radical x. For some reason you might want to rationalize this. It's still same idea applies. You take this, multiply by a copy of the denominator, and you get radical x over x. So this, what we are writing here is a preview of things that you're going to see at the beginning of the next semester. So that's the idea of rationalization here. One step up, when you have multiple radicals in a numerator or denominator, the problem becomes more complicated. Suppose I have 1 over radical x minus, say, radical a. Let's make the problem simpler so that we are sure of what we are after. Suppose I have radical 5 minus, say, radical, say, 3. What should I do? Multiply numerator and denominator with the same thing as the denominator? Well, you have to keep in mind that we are not just following a recipe. We have a goal in mind, and our goal is to make the radicals go away. The goal is not just multiplication. The goal is to make the radicals go away from the denominator. So in this case, you are going to learn that you multiply by so-called conjugate of this. Conjugate means sum of the same two items. Okay, so for difference, the conjugate is the sum, and for the sum, the other pair of the two is with the minus. Well, what is advantage of multiplying something with its conjugate? Let's go back to algebra. If you have a minus b and you multiply by a plus b, what do you get? A times a is a squared, b times minus b squared. You have ab and minus ba, which cancel each other out. So these two, which are referred to as conjugates, have the property that when you multiply them, both entries become squared and then subtracted. So what's his big deal about that? Well, radical 5 is going to get squared, radical 3 is going to get squared, and numerator is whatever you had. So now you have radical 5 plus radical 3. These two items get squared. 5 minus 3 becomes 2. So in this case, all we have achieved is that the radicals from the denominator has gone to the numerator. We didn't save in the sense of reducing the number of radicals and such. We have same number of radicals we had before. It's just the look of the problem has changed. Well, why should anybody care about changing the look of a problem? At the beginning of a calculus, you're going to come to the issue of so-called limits in differentiation, and this type of activity is going to be a lifesaver there for carrying out certain algebra steps. Let's go ahead and do a little bit more so that we are ready for that next course. If you have this thing, you multiply it by, well, this is just like the problem we did up here. You multiply by the conjugate, which is the same two radicals added to each other. Well, what happens? Radical x plus radical a comes up in the numerator. Denominator, either of these two gets squared, and as a result you have x minus a. Okay, now I'm going to leave you with a little bit of a challenge here. Again, we are doing just preview of beginning of our calculus class. This is optional, it's not on your exam or anything. What do you think is going to happen if I had cube root? So think about it, and if you have suggestions and such, let me know. Come to office hours and we will talk about it. Okay, so the main topic was this simpler problem up here. How do you multiply two roots? How do you divide two roots? How do you rationalize expressions that have just one square root in a denominator? And then we said, well, that's not going to be the end of story. There are also other rationalizations that are going to come up later on. Until next time, good luck and God bless.